Good morning, everybody. Hoping that you guys are doing okay. Welcome to the 15th episode of MakerBot Chats. I'm your host, Felipe, Creative Director at MakerBot, and I'm really happy to see you guys again here. I'll give a few more minutes for some people to join. And while we wait, I'll just reintroduce the concept of chats for those of you who might be just joining us for the first time. This is kind of an open platform for us to talk about 3D printing. Mostly about what these printers can do, right? So MakerBot printers, of course. But overall, I think most of the concepts and sort of information that we talk about is pretty general. We try to keep it open. And ultimately, it comes down to the questions that you guys ask us, right? We're trying to touch as many topics as we can, most of them being informed by the questions that you guys might have back home. And yeah, today we have it's an interesting one. It's a kind of one that's fairly technical in nature because we're going to be talking about print time and how does your slicing settings can affect your print time. I've always wanted to have like a full-on test of different geometries and see specifically how much do they differ. So we have three specific samples that we will be discussing today. First off, I'll start with this bicycle pedal. I'm working on a little case study for Method, but it's basically standard bike pedal, right? It has a hole for the spindle to run through. Here's where you would stump your feet. Some features for extra grippiness, openings for just reducing the weight and the material use. Secondly, my trusty propeller. I know that you guys would probably have seen it in many other episodes. I just really like this geometry a lot. It's kind of like an interesting one. It's fairly straightforward, but at the same time has a lot of different nuances to it. The three blades, the internal core, the way that it would actually interact with an axle or the bearing inside, and the fact that it requires supports to be printed. And the final one, it's just one blade of a three-blade assembly, basically a windmill, scale down, of course. But you can see like it's a fairly organic shape. Just twists around. It has a hole underneath that I use to connect it to the actual main hub. So the hub would have the three blades, kind of stacked in a sort of radial array, polar array, if you may. And we will be talking about like these three geometries specifically. How do they differ, and what are the implications of printing them in different ways? Now, let's start with the very basics, right? What are the things that we want to be discussing? And I'll say that, let me change my camera view here for a second. Ever since we got the two camera array, it's kind of been an interesting one for us to work with, just because it gives us a lot more control over what we can be showing you guys, right? We have the two views now. So I'll go over first the settings in MakerBot Print that I'll be changing. I'll show you guys the Excel. I'm tracking all of this in an Excel sheet. And as you can see, I started slicing some of these prior to us entering the conversation, right? Just because some of them might take a few minutes to slice. Specifically, like right now, I am slicing that propeller. So this propeller right here, but I'm slicing it laterally, right? I think that most of us would default to slicing it vertically, meaning on its side, well, sort of with the circular element, the axle element pointing up in the Z direction, right? I'm slicing it sideways just to compare, how does the time difference or how does the time compare between the two orientations, whether you stack it upwards and print it that way or stack it laterally that way. It has different implications, specifically when we're talking about the part strength. In this case, the part strength and the easiest way to print actually correlate nicely, right? Because if you slice it this way with the base on the bottom, you actually get layers that go across the whole propeller at once, right? So you're not having any stresses act up directly against the different layers that you have in your print. If you slice it this way, as I am right now, you might encounter, like you could imagine, sorry, I'm on this camera. You can imagine how as you stack the layers this way, so, right? Some of them will, you can see it here, the layer lines will come right up against that edge that meets, where the propeller and the main body meet. That means that the main point of stress is actually going to coincide with one of the layers, right? That ultimately means that you're more likely to have a failure in the part. So we'll talk about that a little bit more in a second. And while this finishes slicing, I want to show you also my chart here. I started populating this morning with some of the geometries that we will be using, right? So you can see I have my 3 parts: the pedal, the propeller, the blade. Here are my screenshots. I'm missing the screenshot of the blade. And the actual tests that we will be conducting. So orientation A, putting the part in one way. Orientation B, turning the supports off. So how does that affect my print time? Using breakaway supports instead of soluble supports. And by the way, all of these parts will be sliced for the method. Well, in this case, it's a method X, but the time will not change as long as you're using the same materials. And the final thing that we will be talking about is the layer height, right? What happens if I increase or decrease the layer height? The standard layer height with method is 200 microns, and that gives you quite a nice resolution. So let me just show you, if I jump back here to my main camera. This is what 200 microns look like, right? It's an incredibly smooth part. Let me zoom out so that you can actually focus on my part. Here we go. It's really smooth surface. Like, some printers will claim that they can print 10 microns and then that the layer height can go even smaller than that. In all honesty, specifically for FDM, going anywhere under 100 microns is probably going to be a waste of time, just because you're adding a lot of layers to your print without necessarily getting a higher return on your investment, right? It's just the nature of the beast that with FDM, as soon as you start going under 100 microns, it's going to be really hard to have a nozzle, a system, a whole platform. I haven't seen any that actually performs at under 100 microns. I would say that 100 microns is great for super fine details, super delicate components. 200 is kind of like a standard, which is what we use as a standard here in Method. It gives you quite a nice resolution. And ultimately, the resolution is more related to the system as a whole rather than just the layer height, right? The layer height, and that's kind of what we're touching on right now and comparing the print times. Layer height is just one of the variables that you can play with. It's not necessarily the most important one, and it's also not the end all be all. That's my take on it, but you guys can question me on that comment section. And by the way, Alejandra is tracking all of your comments on that question box on the, I think it's the top right in YouTube. So if you have any questions, do post them out there and I'll be answering them at the end of the show. So I'll come back here. We were talking about like the final element, layer height, and all of these numbers will be populated in minutes, right? So I am going to be slicing the different parts and filling up the minutes that I get from the slicing process. These, it's almost ready to go, my last slicing part. I apologize, but you can see, let me move here to my MakerBot print interface. So you can see how I'm slicing as I said before, the propeller sideways. Because of the fact that it's going to be sliced sideways, you can imagine how much more time and support it will require, because instead of just printing it, flat on its side or on its like cylinder element pointing up, I'm also, and that means, if you're printing it this way, that means there's no support requirements on all of those hollow spaces inside of the part. However, as soon as I flip my part, that means that all of a sudden I need to support not only the blades, right? You can see how here with my hand, I will be needing to support the blades, but also all of these internal cavities that used to be just pointing upwards and would not require any types of support. You can see on the image on the right how basically my part is now completely covered in supports, right? Some of the parts require that, whether that's because of the orientation that you might need, because you might need that orientation, as we were saying before, based on the strength requirements. As we say, like, the orientation of your part will change its performance, and it will change how strong it is in certain axes, just because, or axis, just because it's the nature of FVM that between the layers you will have a different component, strength component, than acting up directly against those layers, right? You can imagine how if you have a sandwich and you try to press it from the top down, you probably won't do much other than compressing it a little bit, but it won't be destroyed, right? But you have the same stack of bread, right? And you push on it sideways, it's going to be very easy to sort of topple over the bread and the different layers in this case. I don't know if that analogy makes sense for you guys, but I hope it does. It does certainly help me. So back here to my Chrome window. Oop, here we go. So I'll talk about some of the results that I've gotten already. So orientation A is our standard orientation. And let's start with the propeller, right? With the propeller, I just started slicing it standard, facing upwards with that cylinder aligned with the Z-axis, and we got about 1,400 minutes. Not too bad. Orientation B is what's coming out just now, removing the supports, right? So this is, take into consideration the supports here are just, in this case, I'm using same orientation, so our standard orientation A. It almost more than halves my print time just by removing the supports. Now, not all of the parts are able to be printed without supports, right? Some of them you might be able to live without the supports just because, perhaps you don't mind a little bit of material drooping. This might be just a first pass, a first prototype, and you don't need like super defined edges, so you might be fine. That's a great way to save time, but it's also, the results may vary, let's say it like that. Then using breakaway supports. So breakaway supports are basically, instead of using our soluble supports, you're using supports that are made out of the same material of that which the part will be made, right? So if your part is ABS, the supports will be made out of ABS. But that also means that they are much harder to remove, right? Unlike what happens with soluble supports, with breakaway supports, you will need to remove them by hand, so you will need to think about having a plier or some sort of device that will enable you to remove those supports manually. It's just harder. Some parts, like this propeller, right, in this case you can see like all of the supported areas are exposed and easy to access, so it's easy for me to remove the supports if I chose to use breakaway supports. Which is a great compromise because I am definitely saving a lot of time. You can see how it's close to 1,000 minutes here, so much lower. So here I have my different samples, right? Breakaway supports for the propeller. Propeller are the red columns, right? It's much less than my first orientation, but definitely not as little as my supports off option, right? And as we said, like without the supports, especially this part, it might print okay, but you might be risking it a little bit too much. And it all comes down to just, it's a learning process, and you will probably have to test and see for yourself, like what is your part and what are the different options that you might have when slicing it. And finally, changing the layer height, right? So what happens if I just print with supports in the standard orientation, but with a layer height of 300 microns? And as we were saying before, 200 microns is kind of our standard go-to, not super fine, but also not incredibly coarse layer height. And that almost matches the breakaway support speed. Actually, it's a little bit lower. So you can see how I have 992 for the breakaway supports minutes and 968 for the layer height 300. So just by something as simple as changing the layer height, again, what you're compromising on when changing the layer height, it's most likely the fine elements of the part. In this case, since there are not a lot of dramatic surface changes, it's not a textured part or anything like that, I might be able to just work with the layer height 300, with a layer height of 300 microns, just for the first couple of prototypes, or even for the last one, right? It all depends on the applications, because say this part needs to be later on painted on, or primered or covered or post-processed in some way. A layer height of 300 might be a happy compromise between printing it much faster without losing the ability of using soluble supports. So let's go back here to MakerBot Print, see where we are at on that final slide. Sync seems to be has been completed. Let's see. So one date, 8 hours and 29 minutes. And I'll show you how I've been entering my data into here. So one day, 8 hours and 21 minutes. So what I'll do here, I'll come to the propeller, orientation V equals 21 minutes plus, so one day that's 24 plus 8, that's 32. Actually, I want to use a parenthesis just to make sure that this is correct. 32 times 60, 60 minutes per hour, so 32 hours and 21 minutes. Gives me a grand total of almost 2,000 minutes, right? It's quite a bit. It's quite a big difference between the two orientations. And all I did, I'll go back to MakerBot Print to show you guys how does that look like. It's always fun to be fading back and forth between the different scenes. So all I did here was changing the part orientation, right? So you can see here, this is the way that I'm trying to print, in this specific orientation. It's not ideal, but as I said before, you just might need that sometimes because of the fact that you want to change the way that the layers are oriented against a specific stress. You might want to get a different type of resolution because also that changes, your part orientation, and we can talk about in some other episode. Your part orientation will also change how much detail you can get out of the part. Meaning, if you orient a very shallow part that has a lot of texture to it, like picture like a tile with a texture, like a wavy texture on top, if you orient that flat against the build plate and try to print it, that means you don't have a lot of layers to ultimately define that textured element on the top, right? So just flipping it over and printing it sideways gives you so many more layers to actually have a better definition of the part, right? It all depends. So I'm done now with the propeller, and I'm going to jump into the blade slicing. So let's go ahead and select the different slicing settings that I may have. As you can see here, I'm preparing it for the Method X. I'll just go over some of these standard elements. So ABS for my material, SR30 for my supports. SR30 is our soluble material, as you guys know. My print mode is balanced. I have two print modes, defaults for Method and Method X, so it's balanced. That's our standard, as I was saying, 200 microns, 20% infill, and that's it. And the second print mode is going to be solid, so if I need something that is as close as possible to an injection molded part, I would select the solid mode. My base layer, that's basically the first layer that's going to be in contact between the model and the actual part. That's a raft. So a raft is basically quite literally a raft of material up on which the part will sit down. The raft would just ease the process of removal, help you with removing the part from the build plate, and at the same time give you like sort of a flat zero stage to start your print at. Temperature, I won't talk too much about that. Infill density, I haven't changed that because I'm assuming that, for purposes of this experiment, we're using like that standard 20%. Chamber, layer height, here we talked about it, right? The standard being 0.2 millimeters, so that's 200 microns. Two shells, the support angle, that looks okay. And I'll just go ahead and hit preview for the blade. And while that finishes, let me hide my settings here. I'll go back to my other results, specifically the results for the pedal here. In the pedal, right, I have my pedal here, right, the printed part. I tested the similar or a similar set of settings here. So I tested orientation A, which is basically facing upwards like that. It's not the most intuitive orientation. Why? Because, as most of you will probably want to default to an orientation that is as shallow, as close to the build plate as possible, so printing it this way. In this case, I printed it vertically just because I wanted to make sure that this main cylinder, where the spindle is going to be nested at, was facing up against the C axis. Why? Because that gives you much more control over how the cylindricity aspect of your part. Printing cylinders flat underside means that ultimately you're trying to describe a circle, but you're describing it in multiple steps, right? So you'll have little steps that For most purposes, our perception, it will be really hard for you to perceive the steps on that cylinder printed sideways. But definitely, if you're talking about tight tolerances, like what I'm going to be using with a spindle or with a bearing, it might get to a point where those steps, if you imagine like it's basically Minecraft style, this way of describing a circle, right, upwards, stepping to the sides, will come into play with your tolerances. So you might need to change the tolerances. So that's why I printed it, vertically oriented. That gave me close to 850 minutes. Orientation B, the shallow, the one that's flat up against the side to the build plate, that's about 400 minutes, so way faster, almost half the time, without any supports. And again, my standard came back to being this vertical alignment because of the reasons that I just stated. But without any supports, I got 300 minutes, so I'm saving about 500 minutes. That's quite a bit. And in this case, right, you can see if let me jump to my other view here. Where am I? Here we go. Let me use this webcam right here, right? So in this case, this particular part, I did print without supports. Why? Because I knew that the only supported, or the only parts that would need supports, sorry, I'll just try to make it focus here. The only parts that needed supports would be these two bridging areas, right? And you can see how I did get some defects here happening on my part. However, it's not too bad, and for the purposes of just creating a first prototype, I really didn't mind it as much. For a second prototype, which I might have here, I don't, but actually, if it was a final prototype, I would definitely want to have the supports. But again, if I'm just printing something that can bridge, and if anything, it'll have minor defects there, I really don't mind that too much, to be honest. So I'm okay with that. Let's keep going. So that's no supports, about 300 minutes. If I'm using breakaway supports, right, same material same material for the supports as the actual part itself. So that's 436 minutes. And changing the layer height, to 300 microns, but keeping the supports on as soluble supports, gives me about 541 minutes. So as you can see, it's similar to what's happening with the propeller, right? The fastest way by far to optimize your print time is just to definitely turn your supports off. There are implications with that. Some parts, like I've just shown, are good to be printed without supports. Some others, not so much. And that's something that you end up sort of learning as you go. Now, as we start getting a little bit short on time, let me jump back here to MakerBot Print, because I got the results of my first slicing setting for the blade. So that's 6 hours and 3 minutes in orientation A. So that's 63 minutes. No, what? 363 minutes. Now let's try that same part. Go back to the settings. Just turn the supports off. No supports. Slice it again. And in this part, it's kind of like straightforward, because you can imagine how the only element that will need support in this case is the inside of this cylinder, right? Because that's the only place where my slicer is actually detecting that there's no supporting elements. There's this like freestanding cap inside of the blade, and that's the only place where I was going to be using support. So I do expect this slice to be fairly close to my original result, which is 363 minutes. So I'm expecting this to be in the range of like 300 minutes, just because it's not that much supports that I'm saving. So you can see how the preview is being generated, and I've got 3 hours and 42 minutes. So that's 3 times 60, 180, and 42, 180, and sorry, blanking out here, 222, correct? You can correct me if I'm wrong. 222 minutes. So yeah, you're saving about 40 minutes. That's not a lot of time, but also you're not using a lot of supports to begin with. Let's do one final, actually not the final one, so just breakaway. Again, hitting preview. And with breakaway, similar story. In this case, going back to showing you guys this part, it's going to be not a lot of supports. I don't expect to save a lot of time. However, since this part is fairly deep, it might be harder for me to get those breakaway supports out of there, right? So I don't know, if it was just me, I would say this specific part, you should just print okay without any supports. There's not a lot of exposed elements there. Even if there's a little bit of drooping happening or a little bit of overhangs happening there, it's not going to be visible and it's not interacting in any critical way to my joint. So I should be fine just printing without supports if my end goal is to save as much time as possible, right? If I had to pick between supports, no supports, and breakaway supports, because supports, great, I'll be able to wash them out. Breakaway supports, it starts to get a little bit deep and I might not be able to just get them out, and I'll show you those breakaway supports here now that it's finished slicing, right? So you see that orange part in the center of that core, those are my breakaway supports, and I'm not saving that much time, to be honest. So 4 hours, let's see, 4 hours, and it actually is a little bit slower, funnily enough. 4 hours and 49 minutes, so equal 49 plus parentheses 4 times 16. And for the final bit, the final test, let's see what happens. And as after that, I'll just jump into the questions, see what questions you might have. So I'll go back to my tapered supports and then change my layer height. Where is it? Here, layer height from 0.2 to 0.3, and check the results on that. I'll start looking at some of the questions that you guys may have. So, do you have any setting suggestions for printing small components about the same footprint of your square perch tower by the same dimension height as hollow? So let's say a cube about the same size of the perch tower. Roof thicknesses and shells infill. If you need those prints to have supports, then I would say just give out a good offset between the perch tower and the part itself. If those parts do not need supports, I would say disable the perch tower, because for those smaller elements, it might just not be necessary to have the perch tower. Specifically, you're asking about roof thicknesses, shells, and infill. Again, if it's something very small, you might be able to be better off with just a solid infill setting. For the roof thickness, I wouldn't change that too much, because if you if your end goal is to have more stronger parts, then the roof thickness changing the roof thickness might not be the best way to strengthen the part. I would actually start by increasing the infill or going all the way to a solid part. If you add too much thickness to the roof, you do risk the extruder spending too much time on top of the part and sort of burning away a little bit of that top part. I often optimize the slice settings to print faster, but the estimated time is never equal to the real time. Yeah, that's true. Do you have any advice using a Replicator Plus and experimental extruder? Right, so that is one of the things to keep in mind, right? The estimated time is always an estimate. I think that the slicer team is constantly learning about the actual results versus the expected results, and the most fine-tuned estimates are associated with the standard settings, right? So if you use the standard settings, you'll get as close as possible to that actual estimate time result, just because that's where we have the most experience, or time printing at. If you want to get a better estimate, I think it's just going to be hard, but I would recommend you start learning as you go, right? Sometimes you just know this should be a little bit faster, this should be a little bit slower, but definitely it's kind of part of the problem that we have. All of those custom settings are going to change a lot of variables, right? And we definitely keep updating the algorithm inside of MakerBot Print to make it more accurate, but the one that has been, fine-tuned the most is just the standard one. So that's why you might be seeing a lot of deviation in the print time versus, expected versus reality. Then, okay, final one, 4 hours and 9 minutes. Let me just bring that in to my handy chart. 4 hours and 9 minutes. So this is equals 9 plus 4 times 60. All right. And let me show you the results, because that's the exciting part. So here are my results, right? As you can see, that blade element, it didn't change that much in any of the settings. So it was 360, 200, 280, 250. So it stayed somewhere between 220 and 360. So about an hour more or less, just because of the nature of the part, right? And it goes back to that question that we saw earlier about, hey, how do I get better estimates? And the thing is, it all comes down, there's so many variables with each part that you end up learning more as you go sometimes than the slicer itself. However, I will say this, right? The slicer will definitely give you a very strong guidance on what's going to affect most your print settings. So, for example, on that last layer height 300 change, these 250 minutes on the blade, it might end up being a little bit faster, let's say 230 minutes, but it's definitely not going to be half of that, right? At least in my experience, that's not what's going to happen. So I would say, use it as a good way to gauge your parts. I'll go back here and I'll start saying, thank you guys, but I'll keep answering some of these questions that are still coming in. But if you have any more questions, interesting, kind of the two window array. But anyways, if you have any more questions, you can visit us at makerbot.com/chats. It's always great to see you guys. Or reach me out at Felipe at MakerBot, that's FELIPE at makerbot.com, in our social media at MakerBot, both in Instagram and Twitter. Let's see, other questions. How do you know we talked about that. What should I adjust to help with the platform addition? Been having a lot of warping at the bottom. So definitely you can add glue stick, that usually helps. That's standard glue stick. Depending on the type of material and printer combination, I would need to know a little bit more than that. Is it true that overhangs with a slope greater than 45 degrees will require supports? Yes, and actually you can play with that a little bit more. It doesn't need to be exactly 45 degrees. Sometimes you can get away with 60 degrees overhang and nothing will happen. It all comes down on the complexity of the part and the size of that overhang, right? Can I print at one speed for the first layer, then we talked about this in past episodes. Can I print one speed in the first layer and a different speed for the rest? No, unfortunately, no, you cannot. You can only change the speeds for all of the layers and kind of the specific sequences in the layers. You could, however, change the speed of the raft, you could change the speed of the floor, you could change the speed of the roof, and even the infill. So you can change the speed of different elements of the print, but not layer by layer, but sort of like, how should I call this, moment in the print process. So the roof speed, the infill speed, the shell speeds, that's definitely something that you can change. I'll show you that real quick just before we move on, because I know that Alejandra will kill me if we start spending too much time here, but I could talk about this for hours, Let me just final note here just to answer that question. Faith, can you change the print? So the question is, how do I change the print time and speed on specific, in different layers? That's not possible, but what is possible is to change the speed in specific components. So for example, I could change the print speed on, the inserts, so all of the internal components. I could change the print speed of the outline, so that's the actual shell of the part. In the floors, I think that you can also change the speed of the floor. Yeah, here we go. You can change the print speed of the floor surface. As soon as you start playing with some of these settings, you're sort of exploring, right? Completely exploring. Like, we do spend a lot of time perfecting these settings, and most of them are really, really awesomely fine-tuned. We did spend the time in playing with different values, and this is what we believe is the best way for you to sort of have a smooth experience. But that's definitely an option, right? And there's so many settings here that are under the hood that we could just spend, one episode of chats for each of these settings, and we would probably have, 50 episodes coming in. So definitely spend some time exploring those custom settings. So if you go to in MakerBot Print, just hit print settings and then custom settings. That exposes all of the settings that I just showed, the shells, the roofs. Somebody was asking about the, extending the roof thickness, or you can also change the specific speed of the roof. So you can definitely play with those. I would say if you're more focused on getting the result out of the machine, it's easy to just stay and start with the balance mode. We did spend a lot of time fine-tuning that. If not, definitely jump in right under the hood and try exploring kind of your own settings. But with that last comment, thank you guys so much for joining us today. I hope that you guys that we'll be seeing each other next Wednesday. Actually, we have a new announcement, new product next Wednesday. It's an exciting one, and it's related to all of what we've been discussing today. So join us for that webinar and next episode of MakerBot Chats. But in the meantime, thank you guys so much for being here today. And I'll see you next time. Have a good day.